G'day, welcome to SMAP3D Basic Introduction. What is SMAP3D Plant Design? It is a 3D CAD software for fast and easy design of 3D piping systems used in mechanical engineering, equipment production and plant design. SMAP3D Plant Design provides an integrated software solution for an optimal plant design process chain. There are three links in the process chain. SMAP3D P&ID 2D flowchart is the first link in the process chain and are among the most important documents in the plant design. The integrated P&ID to-do list function provides a simple and easy connection between flowcharts and the 3D model. SMAP3D piping 3D piping design is the second link in the process chain and is highly automated with the SMAP3D piping add-in. The automation is based on pipe specification, which makes it possible to create highly powerful 3D plant design solutions from 3D CAD system. SMAP3D Isometric. The isometric drawing is the third link in the process chain. The piping isometric is a single technical drawing in the form of an isometric representation for the production of piping systems. A few primary functions of SMAP3D plant design includes a full comprehensive library, which is 100% customizable by the customer, automatic generation and modification of complete piping systems. It uses the CAD-NAS purchase part catalog, which is fully integrated, line reduction and extensions. It has the capability of full bill of materials, which you can use in isometric as well, extrusions and OLEDs. Okay. We are going to start with the first link in the process chain, the P&ID. A quick overview of this P&ID application. We have the main menu, the toolbars, the pick menus, the Explorer window, the survey window, and then finally the drawing area. The software switches automatically to the diagram sheet where the symbol or the component with the same name is placed. Strings written like 1/8B in a symbol do display an existing reference between symbols of the same name on different sheets. The first value 1 is the sheet name, the second value 8B is the section number of the prepared horizontal and vertical reference system. If you double click on this red string, it will automatically switch to that sheet that it's linked to. As you can see here, if you double click it again, it will switch back to the other sheet. Right, let's start on our P&ID drawing area. So if we look at this existing process, we must enhance it by adding a connection between the heat exchanger and the vessels. To transport the medium, a pump as main component auto equipment is needed at first. Okay, so we are going to start off by opening up the P&ID database. In the lower section, we are going to search for the manufacturing type, and in this example it's Grundvoss. We are going to choose the first one and we can click OK to select this component. Before placing it, we must rotate it 180 degrees and we can click to place this component. As soon as you place the component data will appear. We are going to define the tag number as P3000 and set it as visible. Because this is auto equipment, we must deactivate the inner equipment option. We can select OK and close this window. In creating this pump, we did the advanced and most effective way of using the component database. But to use this, it needs some preparation in the database. We must set the symbol file's name and must be written down in the database records, and also the pipe specifications. This must be done beforehand. If this preparation can or is not done beforehand, there is the basic way with the symbols menu. To place symbols into a diagram, I'm going to show you a quick example of this. So if we open up the symbols library, we are going to add this symbol, which is the vessel symbol, and we are going to place this in here. So using this function, you have access to already used names in this plant. Here we can select the existing tag B2001, and with this function you can count the next free number in this project. In this example it will be B2002. This database structure can be customized 100% to any customer needs. Now the heat exchanger must be connected to the new pump with a pipeline. To do that, we are going to start a new line from the pick menu. We are going to start drawing the pipeline. That as soon as you finish with the pipeline, we are going to click on that pipeline and we are going to select object data. Now we must type in the data for this pipeline. We are going to type in PL300. From the pipe specifications, we are going to select 100. We want to select the spec 10CA and we want to make it visible. Now, if we right click on the pipeline, you can see that we can automatically switch the flow direction with one click. Next, we need to place a globe valve into the pipeline by right clicking the pipeline and selecting place from specification. This filters the component database. This is where you find the linked P&ID components as available to be used. We select the second globe valve, we select OK. Before placing it, we need to rotate it 90 degrees and place it on the heat exchanger. For the component data, we want to set the value as V3000 and we want to set it as visible. And we can click OK. We are going to save this document and we are going to continue on our CAD model. The next step in our process chain is the 3D piping design. Inside of SolidWorks, you will notice there's two new tabs, the SMAP3D piping tab and the P&ID to-do list tab. In our P&ID to-do list tab, we want to refresh from P&ID project to update the view. An error message pops up notifying us that the information is out of date. It shows us with a yellow triangle. We want to right click the E2001 and select update info from CAD. You'll notice that it will turn green now. The pump P3000 and the valve V3000 is new and is shown as an orange cube. The new pipeline PL300 is also new and is shown as an orange square symbol. First, we must place the 3D model for the pump P3000 into the assembly. To do that, we right click the P3000 and click Place Fitting to CAD. Now the appearing window, we want to select Part Finder 9.6 and we click OK. We want to select the centrifugal pump from the database. We take the pump from standard SolidWorks insert component function and place it using predefined mate references. We want to place it on the edge of the hole and we need to specify additional mates to avoid rotation of the pump. So we want to add another parallel mate. As soon as we exit the mate creation, there's a pop-up message stating that the component was assigned. Notice that there is an additional accessory component that needs to be assigned. This is underneath the P3000. This option is for all customers that wants and needs to handle accessory components from the P&ID database, also in the 3D assemblies. For example, it is the motor that drives the pump, so we need to assign a component to it. So we right click this and we assign the component motor to it. Notice now that all the entries from the components are now green. Next, we switch to the pipeline PL300, which is orange with a small black arrow symbol, which means it still needs attention. We are going to click on the entry and show from 2 points. With this function, the red bubbles will appear on the 3D model, where this new pipeline should be connected. For a correct structure and bill of materials, this new pipeline should be created in a new subassembly. We are going to select the orange pipeline and from the to-do list tab, we are going to select Create Subassembly. To create this pipeline, we need to edit this newly created subassembly from our design tree. From our piping toolbar, we can create a new piping 3D sketch. So we are going to create the route, and the only dimension we are going to place in is the 780 millimeters. So we select Generate Pipeline Path from our Piping tab. We are going to right click our entry PL300_100 and select Assign Pipeline, and then click on the newly generated pipeline path on our left. This takes a few seconds to generate the pipes. Piping automatically uses the definition of the pipe specifications and diameter from our P&ID without further user interaction. To finish this pipeline based on the P&ID information, we need to insert the valve into the pipeline, which is still an orange cube. The position of this valve is set to be directly on the heat exchanger, but the automatic creation of pipes inserted a flange on that point, so we need to delete this first. So if I click on this face and I just delete it, now we can place the missing valve V3000 in the pipeline from the to-do list under our pipeline node. We want to place fitting to CAD. So we right click V3000, place fitting to CAD, and we select the globe valve from our standard insert component feature. Making use of mate references, we can easily place it concentric on our pipeline and flip alignment if needed. We want to apply another coincident mate to correctly place this valve. As soon as we exit our mate creation, a pop-up message indicates the assignment of the P&ID information from the valve to the 3D model. The icon in the to-do list window switches to a green cube. The overall symbols on the node in the to-do list was switched to green. This means from the P&ID point of view, this assembly is completed. However, on the 3D pipeline, the update of the new valve is missing. We need to select the globe valve and recalculate this region. This will add the necessary flanges and update the pipeline. From the finished pipeline, we can now create an isometric drawing with SMAP3D Isometric. This is our third link in our process chain. So to do that, we are going to open a subassembly in its own window, and we are going to click Isometric View. Without changing any settings, we are just going to click Finish to start the creation process. When this process is completed, in a Finish window, the generated isometric drawing will be displayed. This example shows you how quick and easy it is to create an isometric drawing. We can open up this isometric drawing using eDrawings. Okay, going back to our P&ID application. In this next step of the P&ID diagram, we are going to create additional pipelines to connect to the pump P3000 with the two vessels P2000 and P2001. So to start off, we are going to select the line. The arrow button should be on and set to 0.25. Now we can start drawing the pipeline from the left connection point of the pump P3000 to the upper connection point of the vessel P2000. Now we can select this newly drawn line and we can activate the data. So if we have a look at our pipeline attributes, the line number, we can use the functions to add the PL301. We can set the line as visible. Pipe specifications are set to spec 10CA and we want the size of 100. We can click OK. Before we click OK, we can copy these values so that we can reuse them later on. We are going to draw another pipe on the T branch from the existing line to the upper nozzle of the vessel. So we start off with the new line and simply on the existing pipeline, we can open up the object data, and we can use the previous copied values for this pipeline as well, so we can simply paste these values here. Now we need to add additional components to the newly drawn pipelines. Firstly, we need to add a three-way valve on the P301 at the T branch of the vessel. To use the correct size valve, we can take advantage of the place from specification option. So we select the main line, we right click and select from specifications. We will get filtered results, the link between the database and the pipe specifications for the selected pipeline. In this database, there are some components available for the pipe specifications. We are going to select a three-way valve. Before we place it, we set the scale to 1, and we need to rotate the valve 270 degrees. And we can place it on the branch, and the component data, we define the name as V3001 using the known functions. Next, we want to control and check the connection diameters between the components and pipelines. For this, we use the design check function. If we click the design check function, we quickly want to change some settings here, and we want to activate the compare diameters and click run. In the design check window, you get the message stating the entry size and line size must be identical. This means that some connection points and their connected lines have different values. If you double click it, it will highlight the problem area in the diagram. For this example, the line with size 100 is too large for the connection on the pump, which is 80 diameter. This is what the design check found and reported to us for the pump, so we need to reduce the pipeline on its way to the pump. So to do that, we will need to place a concentric reduction symbol onto the pipeline. So we use the symbol from our quick pick menu under miscellaneous. So we are going to place this symbol on the left side of the pump. When it is placed, the component data needs to be specified. We are going to use the tag number x2. The symbol type should be set to reduction. Click OK. The symbol should show 100/100. Display diameters value are automatically taken from the existing pipeline attributes of the line where the symbols is placed to. To correct these, you must change the diameter value on the line between the reducer and the pump connection. So we are going to click on this small line segment, and we are going to change this line segment size from 100 to 80. If we click OK, you will notice that the new information shown is 100/80. To better analyze this pipeline, in the to-do list in 3D, we use the new P&ID function called object groups. With this new and additional P&ID attribute object group, the to-do list can do a much more logical analysis. We are going to start the area function, and we are going to select all the objects that's going to be grouped under PL301. And we want to call this PL301, and we click OK. Next, I want to show you how to create reports and lists automatically from our diagrams in P&ID. There are already two prepared list formats. The part list format counts the quantity of the components, and the component list format lists every single component with its tag number. Every list format in SMAP3D P&ID is template based. This means we must prepare a specific list of symbols before we can use it in a project. We are going to start off by activating the BOM2 of this example. The easiest way to insert a new page is to use the insert pull down menu and select new page. We want to select this template here, and you will notice a new empty sheet is added. To populate the sheet, we can simply right click on this new sheet, and we select update list. We want to change the settings of this list, so we want to change the values here from 2 to 2, and we want to sort by tab, selecting the type and leave the values as 1. So we can update this list and you will notice that the new updated list is shown. Another great thing about this bill of materials, if you double click on a specific component or part, it will automatically highlight in our diagram. Before we continue in SolidWorks, let's save this, and now we can continue. Okay, so switching back to our SolidWorks, inside of our 3D piping environment, we want to refresh our P&ID to-do list. To do that, we simply go refresh from P&ID, and you will notice that the to-do list will update. As I said before, green means the content is assigned and up to date. Yellow means the content has been modified or has been changed. Orange means it is new content which was added and still needs to be assigned. So we are first going to update the yellow components. We use the function update from CAD. Now, in the pipeline node, we notice that there is a new orange entry called PL301. If we expand this, we will notice 3 different pipelines. This was created because of the grouping option used in our P&ID diagram. We need to create a new subassembly for this pipeline and assign each pipeline to the corresponding route. To do that, we are going to select multi-pipeline PL301 and click Create Subassembly. Once that subassembly is created, we are going to edit that subassembly and we are going to start a new 3D sketch from our SMAP3D piping tab. So we are going to start on this circular edge. To dimension it, this line 315 and this horizontal line 1000 millimeters. This line 210. Next, we need to add a pipeline from the T branch to the bigger vessel. So we are going to continue in our 3D sketch environment. The end line is going to be 210. There's going to be a 90-degree bend from this line. The horizontal line is set to 2100 millimeters and it's connected to the vertical line 1500 meters from the bottom. Now we can exit the sketch. Once we exited the sketch, we can generate the pipeline. So in our SMAP3D piping tab, we select Generate Pipeline. Notice that we will get 2 path entries. The first path is from the pump to the smaller vessel. The second path is from the branch to the bigger vessel. We will now generate these 3D pipelines. We start with the first path, the PL301 underscore 100, and assign it to the first path. The appearing dialog is for the T-point. This allows users to control the behavior of the software on the undefined branch. We will skip all for now. Next, we will assign the entry for the second path, the PL301 underscore 1 underscore DN 100. With this, we can see that the branch situation is automatically defined and corrected. Because the output nozzle on the pump is size 80, but the pipeline is defined with the size 100, you must reduce the pipeline directly on the pump. For this, we will need to split the line in the 3D sketch to create a new section that will be reduced to 80. So we are going to edit the 3D sketch again. On that line, we are going to go right click and we're going to use split entities function and dimension it to be 158 millimeters from the pump, and we can exit the sketch. Now again, we want to generate the pipeline for this small section, and you will notice a new pipeline was added. Now only thing left to do is to assign that pipeline. And then finally, we can see that the reducer still must be assigned. So we right click the reducer and we assign the reducer to the corresponding reducer on our left. Next, we will address the missing valve on the branch to the bigger vessel. But there is a reducer T placed on this position, so we must first delete this before placing this valve. So in the graphics area, we click on the reducer T and we click delete. Now we are going to select the entry V3001 and we are going to place fitting to CAD. Predefined mates reference makes it easy to place this valve in, so we can add more mates so that the valve is placed correctly. There's a pop-up message that states that the valve is automatically assigned. Only thing left to do is to update the situation of the pipeline, so we need to select the valve in the piping menu and select recalculate region. After this, all entries should appear green, which means all pipelines and components are now created in the 3D environment. So that concludes our basic demo and introduction to P&ID and P&ID to piping. Thank you for your time and please email or phone me if you have any questions.